Okay, so I've got the motherboard all populated with the components, and I tested out the 5-volt system so far. I'm going to be testing the 12-volt next, but all the 5-volt stuff is all socketed on the motherboard. So I've got a 10 amp fuse going out to 3 and 5 amp fuses. The amber are 5s, and the purple is 3. I have a spare set here. This will bring 5-volt raw in from the main, and then I've got the bulk cap and everything set, but it's dead-ended here in case I ever want to run like anything new where I want to power it on a separate rail, 5-volt rail. But I have the standoffs and the sockets all soldered in. I got my Arduino Nano already socketed, and the Nano provides the control for the overhead PCB, the lighting and scoreboard. That just pops right in there. And there is communication lines going directly to the Raspberry Pi that'll get socketed here. So I have a normal Raspberry Pi 4B that I desoldered the pins from. Normally the pins face upwards, so then you can you do your development on there and put it in a case or whatever. But I set this up in a way that I can actually just socket this, if I can get this in right, and record at the same time. So this just sockets in, and then I've got my standoffs that I'll just screw that down. I'm going to design and 3D print a clamp to hold on to the HDMI out. Eventually I'll run an HDMI to an LCD display on the front of the dartboard. But right now, the Arduino Mega, which is this guy here, I rearranged the pins on this one as well. This one is a little bit more difficult to kind of get in, but maybe it's formed enough. Yeah, good there. And then there'll be a small USB cable going here to here. I didn't want to mess around with dropping USB communication onto the board itself when there's so much power and everything going through. I'm not a super engineer to be able to. A high-speed USB communication is kind of, but anyway, I've got UART from the Nano to the Pi, and it'll be USB to the Arduino Mega. The Mega controls the front panel, and then also up here the dartboard matrix connector. So it'll read the dart throws. This will interpret and send what the dart hit, what segment, to the Raspberry Pi and the Python program that's running to tally the score and run the game. And this as well will communicate to the Pi. And I think it's a two-way communication with the Raspberry Pi and the Nano, but primarily transmit from the Pi to the Nano to display, what the program wants to display, like score and LEDs lit up for dart throws and that kind of stuff. So here's the overhead display. Overhead display. And then that's the matrix, and this is the front button. This also has a MOSFET here to make the light on the player change, blink, or go solid or on or off. And then up here are the lamp outputs for, the stop and go, and then the coin. I don't think I'll ever use it, but, I can have it for attract mode, blinking on and off to make it look nice or whatever. So then here I have the audio amp power output, so we're going to feed the audio amp. And also I have a PWM enabled fan. I've got a old Noctua 120 mil fan, a 4-pin connector. I'll just put a different connector on it. This will be if it gets too hot in, if the pie gets too hot or something, it can enable the fan to exhaust out of the back of the dartboard. But yeah, that's about it. All I have to do is really kind of test the 12-volt rail. So from the GPIO pins through here, I'll be able to actually output audio. So this will go into the input of the amp for the audio input, and then this is the power input to the amp. And these are the two power inputs, the 5-volt and the 12-volt inputs. And those will come from DIN rail mounted Meanwhile power supplies. So, hope you like it.